Welcome to my channel, Krishna Tutorial. Okay friends, today we are going to study about the electric potential. What does it mean? Its definition states that the amount of work done to bring a unit positive charge from infinity to the point within an electric field is known as electric potential. It means electric potential is a work done to bring a unit positive charge from infinity to a point A. That is infinity to A. And its unit is, as this is a work done, its unit is joule, as it is a charge, its unit is coulomb. And combinedly, or in a one word, it is written or known as volt. We represent its unit as a volt and we use it too. And now we understand what is electric potential. Now we are going to derive the relation of electric potential due to unit positive charge. Now we are going to learn about expression for electric potential due to a point charge. And this is the expression, that is V equals to 1/4 pi epsilon naught Q upon R. And now we are going to understand the derivation. I have represented this derivation in a certain point. This is actually to understand. This is the derivation, but I have made it stepwise. If we understand this one, if we understand these all steps, then we can easily derive the expression for this. And I have just cleared it stepwise. And now we are going to learn about it. Number one, we have to know that the force experienced by a point charge, that is a point charge plus 1 or positive charge, unit positive charge, the force experienced by a point charge is equals to electric field intensity at that point. Force experienced by a point charge at point Q is equal to electric field intensity at that point. And the electric field intensity at that point is equals to 1/4 pi epsilon naught Q upon R square. And this is the force which is experienced by a unit positive charge at point Q and which is equal to the electric field intensity at that point, that is the point Q. If we at first, for derivation of this expression, we have in our mind that the force experienced by that charge, that unit point charge at that point is equals to the electric field intensity at that point. Number two, the second thing we have to know is that the small work done on bringing a point charge from Q to P, that is Q to P, we have to calculate this. We are calculating this small work done in order to find out, our main motto is to find out the work done for bringing a unit positive charge from infinity to certain point, that is A. And to calculate that, we just calculate a small amount of work done and just we integrate to find out that. Just our motto is to just find the work done to bring a unit positive charge from infinity to a point A. If we can calculate the small charge by integration, we can calculate the whole or the amount of work done we need. The small work done on bringing a point charge from Q to P, the number second point, which should be in our mind to prove or derive the expression, dW, that is small work done, is equals to force into displacement. That is, the formula of work done is force into displacement, and the force we have from here, and the displacement is, if this is, we have let that the distance between this charge and a point this is x, and if it is x, then this is very small displacement, just we have taken that is dx and we have the formula for work done is force into displacement. Now the small work done is equals to force 1 upon 4 pi epsilon naught q upon r is x square into dx. This negative sign indicate that the work is done in opposite direction. It means because of this the charge is being pushed, but we are bringing it towards it, means here negative work is done. That's why this negative sign just indicate that much. And number 3, the main thing, and we have to that must be in our mind for derivation of this expression is total work done, and this is the conclusion of this derivation. Total work done to bring a point charge from infinity to a point A is work done. It is represented by W infinity A, and the work done to bring a unit positive charge from infinity to A is given by integration of this one. This is small work done, and if we integrate it from infinity to R, infinity to distance R, then we can obtain the required work done. Now we have the small work done is equals to, from here, small work done is equals to 1 upon minus 1 upon 4 pi epsilon naught q upon x square into dx. This from the minus here, I have just taken it out of the integration. As it's constant, doesn't matter. And now we are just this from here. There is just a mathematical calculation. We are just going to integrate this expression. Integrating the expression from infinity to r, and here q upon 4 pi epsilon naught are a constant term. Just that's why we are taking it out from there, and q 4 pi epsilon naught integration from infinity to r x square x to the power minus 2, as it is x square 1 upon x square, that, and that's why I have written here x to the power minus 2 dx. And now just calculating this is the same, and after integration we get x, the integration for if integration is of x to the power n of dx is equals to x and plus 1 upon n plus 1. This is just integration, and we have just written here integrated this x to the power minus 2 plus 1 minus 2 plus 1 as the integration, law of integration formula, and just calculated it. Minus q 4 pi epsilon naught minus 2 plus 1 minus 1 minus 2 plus 1 minus 1 x to the power minus 1 upon minus 1 r infinity, the same, and we get here 1 upon x minus x to the power minus 1 minus 1. That's why this can be written as 1 minus 1 upon x infinity to r. Now, as it is definite integral, we are going to replace the value of x by one time r and another infinity. Then we get here the minus and minus have been positive. That's why I have removed the minus sign, and q upon 4 pi epsilon naught 1 upon r minus 1 upon infinity. Now q upon 4 pi epsilon naught 1 upon r, as you know, 1 upon infinity is equals to 0. That's why we have removed this one, and we get the final required relation q upon 4 pi epsilon naught 1 upon r. Just I have placed q in place of, this can be arranged as per our wish, and the required electric potential, that is electric B, and which is equals to the work done in bringing a point charge from infinity to A is equals to B is equals to 1 upon 4 by epsilon naught q upon r. This is our required relation, and this is for expression. And this much. Thank you for watching my video. If you like it, just subscribe my channel. I will produce more video like this, and which will be, I will try my best to make you understand, simplify that and make you understand. Thank you.